Uh, Welcome, everyone. Happy Wednesday. I thought we'd just start with introductions since this is a working session, and I thought we could at least have the presenters introduce who they are. So I'm Dave Wallace. I am the chairperson of the FIDO TSC. I have been a committer on most of the main projects. I've worked on VPP since prior to its open sourcing. Which was open sourced in 2016. So I'm a committer on the CI management, the VPP, and the CSIT projects. And so the goal for today's sessions is really to introduce everybody to each other. We've got two different StrongSwan plugins that are under development. And so I've asked Kai and Kobe to walk us through and explore what they've got in their solutions and what's in their roadmaps. And then I wanted to initiate a conversation about creating some sort of testing community where we can provide a space to do integration testing with VPP and StrongSwan and what that might look like. I had reached out to Tobias, the PTL for StrongSwan, and unfortunately he's on vacation this week, so he wasn't able to join us. So today's goal is really just to introduce everything, start the discussion of what our common goals are, and then I'd like to host a follow-up session where we can talk about some of the logistics of and some of the issues with licensing and upstreaming and all the rest of that. So anyways, Kai and Gabriel. Kai, why don't you introduce yourself?
Sure. Hey, everyone. Good morning. Good afternoon. My name is Kai G. I'm a Intel network engineer working for Intel Shannon. I've been working for network engineering, networking protocol development, and kernel development in past a few years. I'm recently just joined the VPP team and starting to working through VPP on IPsec and StrongSwan about a year and a half ago. So I'm leading small team into Intel Shannon. Majority focus will be IPsec on VPP development. Yep, that's pretty much my introduction. Yep, for myself.
Great. Gabriel?
Okay, my name is Gabriel Ginsky. I worked in VPP community about 2 years ago. I joined it, so I collaborated together with the Kaiji related to the WireGuard, IPsec, StrongSwan stuff, something like that.
Excellent. Well, thanks for your contributions. And Kobe, welcome.
Hello, everyone. Yeah, I am Kobe Cook. I'm actually joined here by two of my colleagues, Henny Olivier and Robert Delaray. We are a network security company focusing on secure VPNs, and we also committed or port maintainer for StrongSwan on FreeBSD, and we've actually created a plugin to make use of StrongSwan inside of VPP. Yeah, that's it.
Excellent. Well, thanks so much. Welcome. Do you want to drive the presentation or do you want me to drive it? Because either way works for me. I've got your presentation here. I can run the slides and let you talk.
No, we can do it like that. I'm happy to do it that way.
All right. And Casey, can you do me a favor and can you jot down any notes in the wiki, or can you take notes for us?
I will try. I'm in multiple sessions also.
Ah, okay. Let me see. Does everybody else have? Well, I'll try to take notes and we'll just take notes at the end when we start doing discussion. So All right, Kobe, the floor is yours.
All right, so yeah, it's just the introductory slide. We can actually just move on to the next one. So, like I said, just a little bit of background about ourselves. We are in a company called Panotech. We offer layer 2 and 3 secure VPNs, as well as we do secure voice communications and also hardware-based cryptography. We are a port maintainer for StrongSwan on FreeBSD. And where this actually project started was we wanted to have a between 10 and 40 gigabits per second layer 3 VPN. And the initially we tried to port VPP over to FreeBSD, but there were some issues with the VFIO integration in DPDK, and we actually also realized that there were the NetMap port that we used to integrate with VPP on FreeBSD did not actually provide us with the desired performance. So that's when we actually decided to go to a Debian-based operating system and do our development from there. Okay, yeah, can go to the next slide. Okay, so I thought I'd start this by just quickly having a comparison of the aims of StrongSwan and VPP. And as you can see on the slides, the main goal of StrongSwan is actually to support IP negotiation and the management thereof, as well as the creation of the SAs and policies. And StrongSwan actually also offloads any data channel cryptography to either the kernel or a userland IPsec implementation. Whereas VPP does have some support for IP negotiation. You can set up the IP negotiation as well as create the SAs and policies. It also supports the creation of tunnel or tap interfaces to support GRE, IP, or IPsec tunnels. The one thing with VPP is it either needs to be done in config when you load up VPP, or you need to configure it manually. And there's actually no management surrounding the SAs where you want to rekey or destroy the SAs or just generate new keys automatically. So all the management there, therefore, isn't actually present in VPP. Okay, so next slide. So that's where we actually decided as well to create a plugin to support configuration from StrongSwan to VPP as well, seeing that a lot of our other products also actually make use of StrongSwan for our secure VPNs. So what we decided, and I think which is logical for most of us here, is the IP negotiation and configuration of the SAs is managed by StrongSwan, and VPP would be more the workhorse, where it would create the IPsec interfaces, configure the ESP tunnels for encryption to actually get these gigabits per second encryption speeds. So the one thing that, of course, we also need to just mention is that VPP, there may be other requirements as well. Like I said here, about if you are using a root-based VPN, you would need to install routes as well into VPP to ensure that you can actually send the traffic over IPsec tunnels to the other hosts or boxes that you have. Okay, so just a quick overview of our operational environments. This was what we used last year to set it up. Was Debian 11.3. We tested it on StrongSwan 595, DPDK version 2202, VPP 2206, and with the Intel IPsec multi-buffer library as well. So this was all done last year. About this time was the last time we actually sort of worked on this project. Yeah, because it's since stalled a bit, and our priorities have shifted a bit. So we are not actually actively developing at this stage. Okay, so then I think we can move to the next slide. The high-level design, as we see the system and how we have implemented our systems, is using StrongSwan-VPP, the Linux control plane, and DPDK. Where, as I said, StrongSwan would be used for IC negotiation, and it would interface with VPP via API. VPP, of course, is then there to create the ESP tunnels and would replace the normal kernel offloading for the IPsec tunnels that would have been done before anyone used VPP. The control plane plugin, again, is there to actually mirror the interfaces on VPP back to Linux so that you can install other routes or networking services to work with VPP. An example of that would be using dynamic routing or SNMP or any other networking service that you may require. I'm specifically mentioning dynamic routing here because we are actually using, if you want to use a route-based VPN, it might be handy to have dynamic routing enabled as well. So then the last component, of course, is just DPDK, which provides all the data planning, as well as the VFIO and UIO drivers that we can use to interface with any HSMs or cryptographic hardware if you want to go that route, which we as a company also do. And of course, DPDK also includes the multi-buffer libraries from Intel for crypto acceleration. Okay, the next slide is just a high-level design of, a graph of how our high-level design looks, where we have our kernel VPP plugin inside StrongSwan as a plugin for Sharon that you can communicate through with VPP through the API interface. And of course, VPP then has a couple of plugins. The ones that we are obviously interested in is interfacing with DPDK and the Linux control plane to mirror the interfaces. Then at the bottom, of course, you have the Unix kernel with the drivers for, let's say, your network cards that DPDK will obviously grab and then provide to VPP through its UIO or VFIO drivers. So that's that is about how our implementation looks there, and I think it's actually pretty well figured out. But yeah, we can discuss some of the components a bit later on in the session if anyone has any questions. Okay, then the next slide is just an overview of all the functionality that is currently in our kernel VPP plugin. So the plugin will allow for the creation of security SPDs as well as the policies and the SAs. I just want to highlight the one point that I made here about the one SPD on initialization. I've seen a couple of implementations on StrongSwan in the plugin use one SPD per policy when they actually create these SPDs, and that kind of did not make sense to me, and that's why with our plugin we just decided we're going to make one SPD and all the policies are going to be installed into this SPD on VPP. So it's just a bit of something that we did a bit differently than what I've seen some of the other plugins did, and I think it's actually a bit better this way around as well. And of course, for the essays, the normal creation and deletion of the essays have been implemented. Any rekeying or re-authentication that you need, the plugin will be able to handle, as well as any expiration of the essays. Then another thing that was implemented is just a scheduler to handle the rekeying based on timeouts or expiration, which at this stage, VPP does not actually offer you timeouts or the time that the essay has been active. So there's a timeout mechanism built into the plugin itself. And then just of course the statistics that the plugin can provide you at this stage is the byte counts per essay as well as the packet count per essay. And then the next slide will actually show some of the shortcomings that we are aware of in either StrongSwan or in VPP, or in both of them. And like I said, the scheduler only handles essay expiry. Our main focus was actually on tunnel mode and not transport mode. So we do have the implementation for the transport mode, but it has not been tested yet. And the other thing that normally a lot of the StrongSwan plugins do handle is how to update an essay, which at this stage it does not do, because VPP as well only has a functionality to either add or delete an essay. There's no functionality in VPP to actually just update the essay. From a VPP perspective, some of the shortcomings that we are aware of is that the traffic selectors for StrongSwan for IP version 4 and IP version 6 need to be separate. They cannot be combined. Then there are no statistics available for either the policies or the time that the essay has been used. The policies cannot be configured for specific network protocols like TCP or UDP. And the policy can also not be configured to support compression or to put it in a forwarding mode for the policies. So those are the main shortcomings that we are aware of at this stage for all of the plugins. And yeah, okay, then we can go to the next slide. So just a quick mention of what I believe as the session is about, the actual CI/CD implementation. I just thought I'd mention some of the things that we should probably discuss for the testing. And it's actually broken into 3 pieces: the functional test, the use case test, and the performance test. Functional, of course, is just making sure can create the essays, policies, SPDs, test rekeying and statistics. From a use case point of view, I believe there should be testing for site-to-site, VPNs, host-to-host, and the road warrior case. And of course, for the site-to-site, there's the 2 different ways that you normally do it, and that's via a route-based VPN or a policy-based VPN. Then the next tests on the next slides are just the performance tests, and those are the tests that we are usually more interested in, at least from our perspective, is the performance of our hardware as well. So that's the stress testing, load testing, making sure we can actually get the speeds that we want, or determining how many simultaneous connections we can have, as well as making sure that the boxes stay live for as long as possible without something occurring while it's actually in operation. So those are things I think we should probably talk about a bit later on in the session, but just to give everyone a bit of an idea of get the ball rolling on that. Okay. Then the last slide is just about some desired functionality that we would like to actually include in either the plugin or in VPP. And the one thing that I'm aware of is that, at least when we were busy with VPP, is that there's still a manual process for creating the IPsec interfaces after the IPsec tunnels, or after the IPsec essays have been created. Then you need to create the IPsec interfaces and ESP tunnels to actually get traffic to flow. So that is something that I think would definitely be worth including. Then, of course, the integration with dynamic routing daemons, that I think is more when you look at what you want to do with the Linux control plane plugin. And of course, any hardware-based cryptography, which would go through DPDK. For the kernel VPP plugin, as I said, it's basically the same things as what I said. I know the shortcomings were, and that is updating the existing essays and getting some additional statistics for the essays and the policies. And yeah, I think that is our presentation. If anyone has any questions, I'll be happy to answer any.
Excellent. Thanks, Kobe. That's a great introduction to all the work that you've done. Clearly, there's lots of things we can talk about moving forward. I think when we do a follow-up, we definitely would like to invite the folks that are maintaining the Linux control plane functionality, because some of the new feature development that we'd like to see would definitely include those folks. So that's all great. Anybody else have questions right now on the presentation? All right, so let's. Oh, go ahead.
Sorry. Yeah, I don't have a particular question. So maybe we can have a short discussion after our presentation. Would that be okay?
Yep. That's what I was gonna say. Let's get your presentation done, and then we can start to lay up some topics for us to address moving forward. And some of them we will get to today, and some of them will bleed over into ongoing sessions as we move forward. So at this point, you want to grab the screen? Is that you share your presentation?
Yes, if I can, yeah.
All right, so I'll stop sharing.
Thanks. Yeah, please let me know if you can see it.
Yep.
Yeah, we can see.
Okay, perfect. Thanks. All right, guys. Okay, so thanks, Kobe, for the presentation. It's very good. Basically, what we do is actually quite similar. So anyway, what we want to bring for everybody today is the IPsec acceleration with the VPP StrongSwan and the Linux control plane. So basically, IPsec plugin is an important component in FIDO VPP. It provides secure, reliable, and fast networking applications. VPP IPsec using VPP CLI and the VAPI command for easy configuration of secure policy database as a cryptographic algorithm, etc. Okay. Intel multi-buffer crypto library for IPsec is a family of highly optimized software implementations for symmetric cryptographic algorithm. With Intel multi-buffer plugin, VPP IPsec make full use of CPU latest cryptography acceleration instructions, for example, AVX by 12, and which this instruction allow process up to 4 128-bit AES block in parallel. With this on 4th generation of Intel Xeon processor, Sapphire Rabbit, the system performance can reach up to 1.8 terabytes with no drop rate on single IPsec tunneling throughput. However, on VPP IPsec has incomplete IKE v2 implementations, and it relies on StrongSwan to handle SA setup using Internet Key Exchange Protocol. Now the goal is very simple, but actually the implementation to merge VPP IPsec and the StrongSwan is a bit complex. StrongSwan installed the root into kernel routing tables. It expects the kernel diverts the IKE traffic and the process to IPsec data path traffic, both outbound and inbound by itself. What I mean is the encrypt and the encapsulation of plain IPv4 or IPv6 packet, or decrypt and decapsulating for encrypt ESP packet. For a single endpoint, both of IKE traffic and IPsec data flow will be received by the same network adapter. This requirement is introduced by a long-term Linux kernel and kernel bypass problems. The kernel bypass method tried to have the user space take over the network adapter, bypassing the kernel completely. So this means to make VPP and the StrongSwan work together, one must decide whether the VPP or the Linux kernel driver will receive the network packet from the NIC and configure both systems to intelligently route the expected traffic between kernel and the user space, and if needed, transmit to process packet to a second network adapter. To build such a connection between the kernel and the user space I/O, we have tried a few possible solutions in the past. One of the possible solutions we are using AF packet socket interface. And to offload encrypt ESP traffic to VPP, the user must create a host interface, AF packet socket interface, to share with Linux kernel and configure from the Linux kernel side to route the expected traffic to the corresponding interface to VPP. The kernel may expect the decrypt plain packets back from VPP, hence the user has to configure the route properly on the VPP side as well. This situation is similar when the Linux kernel offload clear text traffic to be encrypted by VPP. Configuring such complex routing for both in the kernel and the VPP using StrongSwan control command is quite challenging, simply because StrongSwan must be updated to understanding VPP AF packet socket interface. A single routing entry need to be configured for both kernel and VPP separately. Even if everything is working properly, the overall IPsec throughput will be limited by slow AF packet interface. The alternative solution with the kernel network adapter is using AF XDP socket with a custom BPF filter program. The AF XDP is a socket type for fast row packet processing. It basically allows the network packet to bypass the Linux kernel stack and deliver from the network adapter kernel driver directly to user space applications. AF XDP BPF program can achieve about 11.5 million packets per second with 0% packet loss based on a simple L2 forward micro benchmark shipped with Linux kernel. In addition, instead of passing all traffic packet to user space, it is possible to define static rule to passing only select network flow through a static BPF program. This function adds some flexibilities. For example, you can write a customized BPF program to passing only IP packet with a ESP header to user space through a XDP socket. However, there's also limitation with AF XDP. It basically requires a relatively new Linux kernel. First release was in Linux 4.18, and it's dependent on network adapter kernel driver support. Some advanced features such as a customized BPF program load relies on even newer kernel versions. and also the updated network adapters. Moreover, a BPF filter program is static, and it is very difficult to scale. When a new IPsec SA is created or an existing IPsec SA is updated or removed, the filter program need to be updated accordingly with a new add routing rules and also a newly generated bytecode. Now it's time to introduce a VPP StrongSwan plugin and the Linux CP. So VPP StrongSwan plugin is a StrongSwan plugin that offload the IPsec outbound and inbound data plane packet processing to VPP. The plugin takes advantage of VPP C API that translate the IPsec SA request and the routing rules into VPP socket messages. It's very easy to use. VPP StrongSwan was written, followed the StrongSwan current specifications, and provides a helpful script to compile and install the plugin. The user only need to run a simple command or manually copy configuration files and the compiled VPP StrongSwan plugin binary into the specific StrongSwan installation location, and voila. It has great performance. VPP StrongSwan takes advantage of the highly optimized VPP I/O and IPsec stack. It means network I/O and IPsec data paths are processed by VPP, and the VPP StrongSwan expects VPP to take over the network I/Os, and the StrongSwan expects control plane and the data paths, for example, ESP packet, are shared on the same IP address. VPP needs to find a way to route the incoming IKE packet to the Linux kernel stack and the outgoing IKE packet to the protected network adapters, preferably without a separate routing configuration for them. This is where the VPP Linux control plane plugin become useful. Linux control plane, or Linux CP in short, is a VPP plugin that allows VPP to integrate into Linux kernel. The idea behind Linux CP is to provide a mirrored interface pair between the VPP-owned network adapter and a tap alternate interface linked between VPP and the Linux kernel, so that the network traffic is cross-connected between each other. When the network adapter is added as an IP address to the VPP, Linux CP will be captured the command and automatically configure the tap alternate interface with the same IP address in the Linux kernel side. And it also ensures the packets with the corresponding IP addresses are routed between network adapters and the tap interface with VPP. In addition, the Linux CP makes sure it is the Linux kernel that owns the ARP or network neighbor tables. Also, the entries, although the entries are all copied into VPP. The VPP StrongSwan plugin is included in VPP from 20.10 release and work with StrongSwan 5.9.5 onwards. This is a quick example. We assume StrongSwan expect the IKE message and encrypted ESP packet will have a local IP address of 10.0.0.1 to route IKE packet from the network adapter owned by VPP to StrongSwan. We create a Linux CP interface which binds mirrored interface pair, one network adapter port and the tap terminal port, both with the same IP address 10.0.0.1. In this case, Linux CP helps to configure the routing between the interface automatically. When an IKE message is received by VPP through the one network adapter port, it will be routed to the kernel through the tap internal port, and it is processed by the Linux kernel stack before being processed to StrongSwan. If SA is negotiated successfully, StrongSwan will configure the IPsec ESP flow and routing in VPP through the VPP StrongSwan plugin. Once the automated configuration is finished, VPP will take care of IPsec ESP encryption or decryption, as well as forwarding the packet to the desired port. From this point, since VPP owns both the LAN and the WAN network adapters, It will receive the packet from them and process the routing and IPsec outbound and inbound operation accordingly. When network packets are received by the LAN network adapter and matching outbound security policy rules, they undergo encryption. This process involves adding a ESP headers on the packet. Once encrypted, the packet will be forwarded to the one network adapter port. On the other hand, when network packets are received by one network adapter, they will be checked against any applicable inbound SP rules. If a rule is matched, the packets are decrypted, and the ESP header or terminal header is removed. Subsequently, the decrypt packet is forwarded either to the LAN network adapter or to the tab or terminal port, depending on the IP destination address on the decrypt packet. VPP and StrongSwan will make sure the IPsec bypass drop rules are also handled correct accordingly. The VPP StrongSwan plugin also shipped with a run script for developer to quickly set up a StrongSwan example in Docker images without the physics NICs. With a very simple command, the run script will build up a Docker image from the ground, downloading VPP and StrongSwan, setting up the virtual NIC pairs, assigning IP address and type interface. At last, the configure VPP StrongSwan and the StrongSwan, and which make ready to use. Once you run this, on this host there, we have 2 Docker images set up with both virtual interface, local virtual interface. The Linux CP interface is set up over here, which might be exactly the same as 192.162.0.2 interface. And the IPsec tunneling has been set up in between 2 Docker images. Now, please allow me to pass the presentation to my colleague, Gabriel, and he will give you a very quick demo about the Docker images and the IPsec tunneling setup.
Okay, thank you again, and thank you, and hello again. So let me share my screen. Okay, the first. Okay, sure. Okay, do you see my screen or not? Yes, you can see my screen.
Yes, it's coming up. Yeah.
Okay, yes. So today I'm going to show some example how to establish some connection by our plugin, how it looks before establish any connection in the VPP on also in the StrongSwan setup, and also how it look after establish any one connection. So at the beginning, we need to check if our plugin is loaded, so we can execute command together with the SwanCTL later to get the stats later the StrongSwan, and here it is important to see if our plugin is loaded. So okay, we see that our plugin is loaded, so the first step is made. And also in the VPP, we should check if our plugin also is connected to the VPP by executing command show API clients. And also here we can see that application with the name StrongSwan is connected with our VPP by VIP, and header is okay. So connection is okay. So we can come back to the bus and check if we have something established. So also SwanCTL list stars, and we don't have anything now. And also we can check in the VPP if we have something as SPD, police, or security association. So also show IPsec all, and also we don't see anything. So now we can try to establish connection. So let me copy and paste a command line to establish connection in the bash here. So we wanted to install establish connection the example of configuration is included in the official repository of VPP. So we can try to execute this command, and we see that initialized complete successful. So now we can also in the bash we can check how it looks established connection. Now we see that we have a one established connection between the network to network configuration. Yes, so we have one configuration, and also in VPP should also be visible setup for this. Yes, so okay, maybe I and this. Okay, so we have two SI, and also we have SPD, and also police inside this SPD. So config is done. So now we can try to test. So by send a ping, for example, let me show a graph. Yes, because it will be better to me to describe better. So for this Docker, we wanted to ping the another side, the Docker, the second Docker. So now we send ping from kernel. It will be to by this interface, it will be served by this virtual pair, then VPP will be encrypt this packet and will be sent again into the second Docker, and the second Docker will be received, then will be decrypt the packet, will be see that it is echo request, then we send reply by echo reply, so will be again encrypt this packet and will be come back to the VPP. VPP will be decrypt and will be sent into the kernel space. So we can try to achieve this testing. So in the VPP, before we need to preparing our tries. So to tries, click tries. So we delete our logging, and we also try add a new tries of packet input 100, and also we can ping the another side by ping here, and we change to 200 to 100, and we see that we send the ping, and also we receive some ping, and also we can check how it's going into VPP, and we see that we have some incoming packet. Yes. Incoming packet from our local IP address, similar as we have here. Yes, and we wanted to send packet on this IP destination, and we can see that we encrypt this packet. Yes, and we and after this encryption, we have ASP header, so we have a tunneling, and we send this encrypted packet into the second Docker, and that the second Docker sent to us again an encrypted packet, like here, yes, as ASP header. So it is opposite IP address, and we decrypt this packet, and also we send as plain text as ASP packet into our kernel. Yes. And also we can check if we see any incoming and outgoing packet in the statistic for everything. Okay, we see that 6 packet was encrypted, and also 6 packet was decrypted, and also we can see the same situation in the bus. Yes, and we see that 6 packet was incoming and 6 packet was outgoing. Yes. And also after this testing, we can terminate our connection by this command line. Now, okay, terminated was completed, successful. We can check if we have an established connection. Yes, we don't have anything, and also we can check if we have something in VPP, and also we don't have anything. So I think that it was everything from my side.
Brilliant, thanks, Gabriel. Yeah, so this kind of complete our presentation for today. We are currently working instead of a StrongSwan plugin, we're kind of focusing on VPP IPsec. So we are currently trying to introduce root-based mode into our IPsec plugin. The policy mode is working, is currently already upstreaming, but we're now looking forward to adding the root-based at the moment. I think at this stage, all the IPsec all the VPP IPsec plugin and the StrongSwan plugin are already merged in the VPP source code repo, so it's ready to use. So I think CSAT level has already done the validation test on the StrongSwan. So this is the current situation we're having at the moment. Okay, I think that's all from our presentation. Thank you very much, guys. So any questions so far?
Well, thanks, Kai. That was excellent presentation. So we've just time checked. We've got about 12 minutes left. And so at this point, I guess we can just do a high-level discussion of what what we do moving forward. So clearly, we've got a couple different StrongSwan plugin implementations. The roadmaps for each of them are not necessarily aligned. I know from my discussions with Tobias that there are licensing issues with upstreaming what we have in the VPP repo at the moment. And so that's a discussion that we don't have time to deal with that, and they're not, since Tobias is not here, that's a whole nother meeting that we'll have to have just to talk about upstreaming. And so question for you, Kobe, I understand that your company priorities have changed a bit. Are you still on track to try to upstream your plugin, or what's the status of the work that's ongoing at the moment?
Yes, no, we're actually waiting on Tobias to actually upstream it, or so that was the process. So we've started that again. We started it with last year, but yeah, no, that's still definitely going to happen.
Okay.
It's just when it's going to happen. So.
Okay, great. Yeah, and I open source is a volunteer, for a large part. So I understand that oftentimes when we're working in a corporate environment, we tend to set deadlines that are date related, but in the open source world, we tend to end up having things that are aspirational and they get done when they get done. So yeah, that's kind of the way things roll.
Yeah, sometimes in the corporate as well, you start and then you realize, okay, your priorities have shifted. So
yep,
that also happens.
So for me, we've got, I'm not looking to try to unify the plugins. I don't know whether that's even worth doing an analysis of whether what you've got and what is in the VPP repo is compatible at all, or where that is. I mean, I'll let the current code maintainers, now that we've shared our overall designs and architectures, the code's all open source, so we can take a look at that. And so the next question really is, and exactly the test points on your Kobe, your presentation were exactly what I had in mind. And as I run the CI in Fido, or I help run the CI in Fido, and I maintain it. And one of the long-term goals for CSIT. Now, are you familiar at all with CSIT in the VPP land?
I'm not at all.
So CSIT is kind of unique in the open source world, and this was, VPP is very tightly focused on performance. And so part of our goals from the get-go was to build a performance test suite that really made sure that we had the ability to verify that in addition to functional testing, that we actually have performance testing integrated into our CI cycle. And so CSIT is a performance test lab. We have cutting edge hardware hardware that we set up in test beds there. Please feel free to go join. We have weekly CSIT meetings, community meetings. If you go to the FIDO wiki, you'll be able to find the information on when we have meetings. And the overall goal and what we do is we have trending testing that runs weekly, and we have per release testing that tries to cover pretty much everything across the spectrum of hardware. So we have ARM hardware, we have Intel hardware, we have Intel NICs, we have NVIDIA, or actually Mellanox NICs. They're NVIDIA, of course, bought Mellanox. And CSIT is a performance test environment where we validate and we verify VPP performance. And what I'm trying to do is find a way to extend that to really cross community use case testing. And it was something that was part of the original test architecture when we started the community, but as everything else, consumed our resources, we've never actually gotten to that point. So this is my attempt to go try to see if we can spin that up somewhere. So part of that means we would really need to go find a place that has hardware that we can stand up and run that testing. Right now, the resources in the CSIT performance lab are highly utilized and they're very, very tight. So we may need to go try to find a way to host some on-demand hardware testing environment, kind of like in Equinix Metal or something like that. So that's all kind of TBD, but the first order of business is to find a place where all of our plugins can get built and VPP built and specify, things like what versions of what are we going to test against, and how do we at least set up the build and artifact generation end of things such that when we have a place we can go actually execute tests. And maybe we can find space in the CSIT lab to pull artifacts from some other environment where we could we could build the artifacts that need to be tested and then have it run in CSIT. But that's kind of to be determined. So I guess at this point, the question is, I don't think we have time to actually delve into any of the details of that right now. So I'd like to put that off on to follow-on discussions and include Tobias on that, and just get general feedback on, what are folks' thoughts on the overall goals. And maybe we end up standing up a separate community that's GitHub based to go create the infrastructure to allow the use case testing to be created. So what are folks thinking right now in terms of, I'd love to hear some feedback.
I actually kind of like what you already said about having different hardware tested, because that's always been one of the things with us as well, just to qualify our products for testing. I mean, we have a full operating system that we need to install on the boxes and then configure it and set it up just to do a basic test on a lot of these things. So if you already have sort of a framework to automate that, then that's already a big plus, in my opinion.
Kai, what are your feelings on how do we move forward from your end?
We are very interested to see the work which Kobe just present, and overall we also currently working on the root base for IPsec VPP IPsec plugins, or definitely something we would like to see how their solutions, is if there's any way we could to discuss this, that would be really, really good or benefits for both team. Also, we're glad to see Kobe's team also using epicycle multi-buffer plugins or even hardware accelerations. And we are also working closely with DPDK teams to enrich the QAT hardware features support. So it's definitely good for us to see that as well.
Excellent. All right,
Yeah, we
anybody else have any thoughts?
Yeah, I just wanted to mention, we actually already tested it with the QAT, and it does work. So.
Oh, excellent. How the
Yeah.
performance like?
That's well, we only have NICs that go to 10 gig, and we maxed it out. So.
Excellent, excellent.
Yeah.
So any other?
Yes, I was just wondering about because I know T-Rex also uses DPDK to actually just generate the performance testing. Does your framework use something similar, or?
So the CSIT lab uses T-Rex as our traffic generator. And so we do have dedicated machines as a part of our test beds that generate the traffic and do the performance measurement. So that's all part of CSIT. So yeah, that's where we and like I said, we have a whole range of CPU families, and we have everything from 10 gigabit NICs to 100 gigabit NICs. We're working on adding ConnectX-7 200 gigabit NICs to our test environment. So yeah, so that's all a possibility. And so that's why I think it would be valuable for you to go spend some time, and I can help answer questions or help you get started with CSIT. And the CSIT meetings happen weekly, and join if you can. They're at let me see, they're at 8 a.m. Pacific time on Wednesdays.
Yeah, well, I think we'll definitely be interested to have a look at exactly what it's doing, because it sounds a lot like you're doing a lot already. What's sort of on our wish list, or what we would like to do with some of our testing. So
excellent. All right, well, we're almost at the top of the hour. So any other final thoughts from other folks? Well, thank you everybody for attending this session. Special thanks to Kobe and Kai and Gabriel for their presentation and demo. That was all excellent information. We will take this and post this in a public place. The FIDO website has a webinar type event, so we'll make this publicly available so that additional folks that weren't able to make this session can join. And I will reach out and set up another meeting. I will most likely use the FIDO Zoom meeting space. We have a technical working stream slot that we can use for technical discussions, and I'll invite everybody that is interested. So and Kobe, and if you guys haven't already joined the VPP mailing lists, feel free to do that as well.
yeah, no, definitely we will. Thank you.
All right, have a great day, folks.
Thanks a lot.
Thanks, Dave. Thank you. Thanks, Kobe. Thanks, everyone. Bye-bye.
Thank
Take
you.
care, everybody.
Bye.